Hey, I'm back with some updates. I finally managed to make the whole Merkle verification work. So now I'm trying to also implement it inside of the chain, but this is work in progress, so I'm not gonna go there now. But we have this Merkle verification here now. Merkle verify, and another one. Let me just see how it's called. Something with comparing, verifying chunk hash. Did I close now the Merkle verify? Yeah. Okay. So I'll open it again. So what we do here is we are getting feedkey hash index, which is basically index times 2, and version, which is the length of the whole feed, signature, and the nodes. So nodes are objects which have index, hash, and size. And then we basically check what is our first node. We call it next because we will be looping through, and this next will always update. And the first one is the node with hash index. So index times 2. Why? Because this is how Merkle Merkle trees work. So if we have, for example, I think in our example we have a index, whichever index, but length 14. So for example, if this is a verification for index 4, then we take hash index, which is 8. So index times 2. Then we take the roots. Roots are these last indexes that then create this checksum. And this is the root hash. So this function that we call here tree.fullRoots gives us basically just indexes, not the whole nodes, but just indexes. And then we are looping through all the nodes until we get to the root node. So we start with this, with 8, and then we find the sibling, and then we find the parent, and then we find the sibling, and then we find the parent, and we find the sibling, and we find the parent. And when we get here, we are at the root node. So then we do another thing. So here in this while loop, we are basically searching for siblings, searching for parent, and hashing them together. So hashing them, those siblings together, gives us a parent. And then we find the sibling of a parent and hash them together and get another parent, and so on. But when we get to the root node, we get that root node and we check if our next, basically the current node that we are checking, the hash is the same, so that we know, okay, this is actually the right root node. And then we compare it to this next hash and root node hash, and then we also verify it. And this verification means we grab nodes because we just have indexes from the roots, and then we create a checksum using the hypercore-crypto. And after the checksum, we do crypto verify, and we pass in checksum, signature, and feedkey. So this verifies the whole thing. I am verifying the chunks before hoster stores the data, and in the storage challenge when the attester receives the data and has to verify if this data is correct. And now we will do another verification on the chain because we report to the chain, and yeah, that's it.